So these are some of the outline. What it means by knowledge, different type of knowledge, and what is knowledge representations, different type of knowledge representations, and the last part is about data pre-processing. Okay, so this is a quote by astronomers. So it said that data is not information, information is not knowledge, knowledge is not understanding, understanding is not wisdom. You can find several other similar quotes, almost similar, trying to differentiate what's the difference between data, information, knowledge, and wisdom. So there's a big distinction regardless wherever the field. But as for AI here, we're going to distinguish what's the difference between these four terms and how we're going to apply it in our area. So what is knowledge? So you can see knowledge here is on the third stage here. So what is knowledge? So knowledge is a very general term. It's a progression that start with data, so which is limited with limited utility. So by organizing or analyzing our data, we understand what the data means. So after you have organized and analyzed the data, it becomes information. So that's the next stage. And the interpretation of this information, it gives us knowledge. So that is knowledge. And understanding the principles behind that knowledge, and we get wisdom. So in computer, so we're going to retrieve what is knowledge and how we're going to represent it for our applications. But for wisdom here, so this one is applied for human. That means we start with data. From data, when we process the data, we got the informations. And when we process the informations, we get what we have as knowledge, like the things that we learn in our lecture. And by understanding the principles and how we're going to apply it, and then it becomes wisdom. That's how a man become wise. But for applications in computer, we're going to retrieve what's the knowledge that we can present to our computer, our machines to learn. So from data, by organizing the data, you got the informations. Interpreting the informations, you got the knowledge. And by understanding the principles behind it, then we get the wisdom. In detail, what is knowledge here? So data is a view of collection of disconnected facts. For example, it is raining. Informations, it provides answer to who, what, where, and when. So for example, in the statement here, the temperature dropped 15 degrees and then it started raining. So it provides us with the what and when, like when it started to rain. And for knowledge, knowledge emerges when the relationship among the patterns are identified and understood. For example, if the humidity is very high and the temperature drops substantially, then the atmosphere is unlikely to hold the moisture, so it rains. Provide us answer as the how. And the last one for wisdom is the pinnacle of understanding. So this is like the ultimatum. It provides answer as why. So example like encompasses understanding of all the interaction that happens between raining, evaporation, air currents, temperature variance, and changes. Again, for machine, when we try to provide something to the machines, usually we provide knowledge and it will provide us answer to the how. Show us the relationship and answering the how. For example, like if the humidity is very high and the temperature drops substantially, then the atmosphere is unlikely to hold moisture, then it rains. Here we provide two variables, like the variable for the humidity and the temperature, and we can identify what's the relationship between these two, and we can predict whether it is going to rain or not. That is when we provide knowledge for machine learning. Data and information deal with the part based on gathering of facts and adding context to it. So knowledge deals with the presence and it enables us to perform. And with machine learning, we provide them with the past and the current data that we have, then it can perform. And wisdom deals with the future, so it's acquire vision for what will be. if you look at this graph here on the y-axis, this is the degree of connectedness, and this is the degree of understanding. Okay, so we have looked at distinctions between data, information, knowledge, and wisdom. We try to understand the knowledge here and how we can apply it for our machine. So there are different types of knowledge. We have procedural knowledge based on rules. We have structural knowledge, relationship between concept, object and concept. We also have declarative knowledge based on facts, heuristic knowledge, rules of thumb, and meta knowledge, knowledge about knowledge. What are the different knowledge here? So for the first one, for the procedural knowledge, so it describes how to do certain things, provide a set of directions of how to perform a certain task. For example, how to drive a car. And declarative knowledge, it describes objects rather than the process. So what is known about the situations? So for example, it is sunny today and cherries are red. So this is declarative knowledge. And for meta knowledge, is knowledge about knowledge. So it's a deeper knowledge. So the knowledge that blood pressure is more important for diagnosing a medical condition than eye color. So it's like comparing different kind of knowledge. Then we get understanding like the knowledge which one is more important. For example, blood pressure is more important than knowledge about the eye color. And heuristic knowledge is the rule of thumb. So for example, I start seeing shops, that means I am closer to the market. Heuristic knowledge is sometimes called as the shadow knowledge. So it's based on rules of thumb or common knowledge. There's a term for it, common sense, so heuristic knowledge. And we also have like structural knowledge, so it describes structure and the relationship. For example, how the various parts of the car fit together to make a car, based on structure and the relationship of the object. Based on the different knowledges now, so what is knowledge representations? For computer, it requires a well-defined problem description to process and provide well-defined acceptable solutions. So if you look at this image here, so the upper part is the informal, the lower part is formal. For us, when we have a problem, and we can solve it and we can provide us solutions. But in order for a computer to solve the problem, we have to represent it into different kind of form for them to understand. So we need to represent it, and the computer then only able to compute it and provide us with the output. And this output is need to be interpreted for our understanding. Computer here to collect fragments of knowledge. First, we need to formulate a description in our spoken language, and then represent it in a formal language so that the computers can understand. So which is this part over here. For example, if you're going to predict whether it is going to rain, and then you have your data. So you have data for humidity and you have data for temperature. So you have to represent it in a way that the computer can understand that data. Then when the computer can understand the data, then only it can compute, and then it can come up with the predictions whether it is going to rain or not. So based on our example with the humidity and the temperature given, so there's the output here, maybe the certain graph, then we're going to interpret it, then only we can get the solutions. So that's how we're going to use knowledge representations for our machine learning and how to solve it to come up with solutions.